Hi everyone, in this video I am going to explain third subtopic, that is structural representation of organic molecule. So organic molecule represented with a different formula. They are organic molecule represented with four formulas. They are complete structural formula, condensed formula, bond line formula, and three-dimensional formula, three-dimensional representation of molecule. So organic molecule represented by four structural formulas. Four structural formula. ఏంటవి? They are first one, complete structural formula. Complete structural formula. Second one, condensed structural formula. Third one, bond line structural formula. And fourth one, first one complete structural formula, second one condensed, third one bond line, fourth one three-dimensional representation of molecule. Three-dimensional representation. So in that first one, complete structural formula. First one, complete structural formula and condensed. Comparative system. Complete structural formula and second one condensed structural formula. Complete structural formula and condensed structural formula. So these two are comparative examples చూద్దాం. Methane CH4. So for this condensed formula, just CH4. No need to write carbon hydrogen bonds. Ethane CH3 ethane. Condensed formula, no need to write carbon hydrogen bond, so CH3 condensed formula. Third one, propane CH3 CH2 CH3. Propane complete structural formula. Condensed formula CH3 CH2 CH3. Okay, from this you no need to even represent carbon bond also. CH3 CH2 CH3, like that. So for isopropane CH3 CH or isobutane. I am saying for isobutane. For this, how to represent? This is like condensed formula CH3 CH. This one not present in the parent chain. This is some branch. So branch denoted within the bracket. like this. And continuation, after CH we have CH2 and CH3. This is three-dimensional, this is what condensed formula. How to write condensed formula? So condensed formula in the sense some short form. And if you see hexane, CH3, CH2, 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 CH3, pentane తీసుకున్నాను. Okay, pentane, 5 carbon atom. In condensed formula CH3, between two CH3s, how many CH2s? So 1, 2, 3, 3 times CH2. Okay, and CH3, CH3, between two CH3, how many CH2s? 2 CH2. This is condensed formula, very short form anamata. Next, third one is bond line formula. That is important. So take screenshot. Next I am going to explain bond line structural formula. Bond line structural formula, third one. Third one is bond line formula. Or bond line representation. So in bond line formula we do not write carbon and hydrogen atom. Only bonds between carbon are denoted with lines, and different bonds represent in a zigzag. See this? For example, if you see CH3 single bond CH3 like this, CH2 double bond CH2. This is bond line formula, and this is complete structural formula. So at least 3 carbon atoms unte representation, bond line representation, complete formula. So I am writing propane CH3, CH2, CH3. Its bond line formula like this, zigzag. Zigzag means minimas and maximas like this. And butane CH3, CH2, CH2, CH3. For this 4 carbon atoms, every end of the line, every turn of the line assumed to be carbon, like that. So for pentane CH3, CH2, 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 CH3, like this, pentane. If a branch is present like this, then how do we represent this in bond line formula? This is like this, 1, 2, 3, 4. So, and here a branch like that. This is bond line formula, very simple. Here note what we do not write. We do not represent carbon and hydrogen atom. represent carbon. We do not represent, we do not write carbon and hydrogen atom. Carbon and hydrogen atom. Carbon and hydrogen atom. Next, only the bonds between carbon atoms are only the bonds between carbon atoms are denoted with zigzag lines. The bonds between carbon atoms are denoted with zigzag lines. Next, if carbon atom hydrogen is attached to heteroatom, if hydrogen atom are attached to heteroatom, heteroatom means other than carbon atom, heteroatom, they are shown in formula. For example, CH3OH. What is bond line? Sorry, ethyl alcohol తీసుకుంటాను. For ethyl alcohol, CH3, CH2, OH. So for this, so here carbon, we are not writing carbon with hydrogen, carbon. This hydrogen, because this is not attached to carbon, this is attached to heteroatom. So which is represented? Carbon attached to, hydrogen attached to carbon, we do not write in formula, but hydrogen attached to heteroatom, we will write in formula. Okay. Next, we need to remember this is important, or otherwise I will write here, every end and turn of zigzag line represents carbon with carbon atom with appropriate number of carbon atom with appropriate number of hydrogen atoms. Appropriate number of hydrogen. Appropriate number of hydrogen atom means to satisfy valency of carbon. So what is covalency of carbon? 4. To satisfy covalency 4, to make bonds number 4, required number of hydrogens are there. Required number of hydrogen. So every end of the line is carbon. See here, this is carbon. This is carbon. End of the line and turn of the line is carbon with appropriate number of hydrogen. Every end of the line, turn of the line is carbon with appropriate number of hydrogen atom. So here how many bonds for carbon? Only one bond. So remaining 3 are what? Hydrogen. Here 3 hydrogen. Here for this carbon how many bonds? With this carbon 1 bond, this 1 bond, 2 bonds. Remaining 2 are hydrogens. Here 1 bond, remaining 3 are hydrogen. Here CH3, here 1 carbon with only 2 hydrogen. CH2, 1 carbon with 3 hydrogen. CH3, CH2, CH3. Here every end of the line is carbon and junction also carbon. Turn of the line carbon. Here what? Carbon with appropriate number of hydrogen. So how many? Only one bond, 3 hydrogen. Here 2 bonds, so 2 hydrogen. CH3, CH2. Here 2 bond, so 2 hydrogen, CH2. Here only one bond, so 3 hydrogen, CH3. CH3, CH2, CH2, CH3, like this. Here carbon with 3 hydrogen, carbon with 2 hydrogen, carbon with 2 hydrogen, carbon with 2 hydrogen, carbon with 3 hydrogen, like that. Here carbon with 3 hydrogen. Here for this carbon 3 bonds are there already. Only one hydrogen, CH. Here CH3, CH2, CH3. This is bond line representation of organic molecule. And lastly we have what? Next is, for example, cyclic compound, bond line formula cyclic compound. So I am showing CH2, CH2 and CH2. For this, what is bond line formula? Just a triangle. If it is cyclobutane, forget about IUPAC nomenclature, we will discuss in later classes. So for this cyclobutane, just a square. Bond line formulas. These are bond line formulas. Okay. Next is what? Fourth one, 3-dimensional representation of organic molecule. That's the fourth one, 3-dimensional representation. 3D representation. 3-dimensional. 3D means 3-dimensional representation. 3-dimensional. Short ga manam 3D antam kada. 3D representation. 3D representation of organic molecule. This is last one, fourth representation. So here 3-dimensional representation of organic molecule on paper or on the board, paper or 2-dimensional. On 2-dimensional paper we represent 3-dimensional molecule. How it will be? Three-dimensional representation of organic molecule on a paper by using wedge and solid dashes. Wedge and solid dashes. See here, for example, CH4 molecule 3D representation. Okay, and one is wedge dash and this is what? Solid dash. One is wedge dash, one is solid dash. Okay, so if you see, these are normal lines. normal lines, and this is called what? Wedged dash, wedged dash, and this is what? Solid dash. So normal lines represent 3 points here. Normal lines represents the bonds on the plane of the paper. Normal line represent the bonds which are present on the plane of the paper. Next, normal lines means normal lines and normal represented like that. So next, wedged dash. Wedged dash represented like this. Wedged dash represent the bonds out of the plane, out of the plane. Not only wedged dash, even solid dash also. Solid dash represented like this. Represent bonds out of the plane of the paper. Normal lines represent bonds on the plane of the paper. Wedged dash and solid dash represent bonds out of the plane of the paper. So suppose like this. This is one plane. Board is my plane. On this two bond. Next two bonds are out of the plane, not on this plane. One is towards you, one is away from you. So that means this one, this solid dash, bond towards observer, bond towards observer, not on the plane, not on the plane of the paper. It is out of the plane, it is towards you, towards observer. Next, these are bonds away from observer, out of the plane, away from observer, away from observer. So that means this is on the board, these three atoms on the board, carbon with two hydrogen. Next, this is the one, not must be a carbon, anything, that may be anything. And this is out of the plane of the board, it is towards you like this. And this is back side of the board, this bond we need to understand, this is back side of the board like that. So tetrahedral shape, this one, tetrahedral shape, three-dimensional representation of molecule. Okay, planar shape, sp2 hybridization, sp hybridization, planar. They don't have three-dimensional representation. It is 4 sigma bond. All are 4 sigma. 4 sigma means sp3. That means tetrahedral. For tetrahedral molecule, we have three-dimensional representation. Okay, three-dimensional representation of organic molecule. So thus we represent organic molecules in 4 ways. One is complete structural formula, second representation, condensed structural formula, third one bond line representation of organic molecule, and fourth one three-dimensional representation of organic molecule. Hope you understood. Thank you.